In this video, we will completely change gears and start working on analyzing text. And this class will do some simple textual analysis, and really what we're going to do is work on some regular expressions. Then we'll turn to some other tools in the next class. First, I have some sites here that you can look at. So this first one gives you the package that we're primarily going to work with. And this is the Stringr package. And it has a bunch of explanations for you. There's this great cheat sheet. Of course, understanding what it does takes a little bit to learn. But all of this is this package, and the things we will do during this class are based on things called regular expressions. So there are a bunch of sites. If you just look up regular expressions, it will explain what they are to you. But this is one you could go look at. The main part about regular expressions is what they are doing is they try and match characters in text, and that allows us to have tools that can generally look up lots of pieces in text. So the text we're going to work with here is this conference call from Tesla. So all I did is copy and paste the record of a conference call, so you can see at the beginning it's talking about who's on the call, and then says, okay, welcome to this conference call, and then a bunch of discussion here. So you could read through that to understand what's happening, and sometimes that's more important than the analysis we're going to do. But other times there are textual things that we might want to quickly pull out and understand what some body of text is being used for. And this is useful in a few ways. Sometimes you have lots of documents you want to look through, and so this happens on sites that will search through text. They're using these sorts of tools. Or when you're looking through some, like a large set of financial filings, or through press releases or the news, lots and lots of tools out there that are looking at textual data. This is helpful for us in not only in looking at textual data, but then as later we turn to pulling information from websites, that is not always set up in a nice way, so then having a few extra tools in your tool belt are helpful. So let's start with this Stringr library. So I'm using these functions here. Stringr is the primary one we're going to be dealing with. readr, we've already seen. Tidy text and text data give us some tools to get some sentiment measures, and we'll use them later as well. So I'm going to read in this read file. It just reads in the text as one long character. So notice over here I've got this value that is temp, and it is just the whole text of the conference call. And even as I'm hovering there, you can see it's got a lot of characters in there that they're formatting characters that tell it go to a new line or things like that. So some of those introduce some challenges, but now we have this large character string that we can use to do some analysis. And now let's start working with it. This is the Stringr function, an easy one. We can just do the length of the string. So how long is temp? And it tells us it's got 46,225 characters, but that's not really that helpful to us. It does give us an idea of how long it is, but there might be other things that we want to actually do. So let's try a couple of those things, and that is what we're going to do here then, is introduce other functions and some of the regular expressions that help us do this. So the next one, and all of the functions that are in Stringr primarily rely on this sort of setup. So string count, that's going to count how many instances a certain pattern shows up in the data. We're going to use temp. That's the same character string that we're working with. And then here it's using, and there are different ways to do this, but we're going to use what is this regular expression function. So what it's going to do is the pattern that it's going to match is this regular expression. Of course, you could just, instead of that, you could just put a pattern directly in here. So for example, let's try that. So later we'll do something like that, but if we just want to put in something that says match how many times it says company in the character string. Then it counts and says, look, it comes up with 5 times that company shows up in the string. But the regular expressions gives us a little more flexibility, so let's talk about some of what goes into that regular expression. The last things here are options that allow you to decide whether to match things one way or another. So ignore case says, don't worry about if it's uppercase or lowercase, so it'll match anything that is upper or lowercase, so that can be useful sometimes. The dot all is something we will see in a little bit, but it is the period, the dot, matches any character. And so here it's saying, does that include matching other things that it may skip? So for example, going over a return character or something like that. So here, yes, it'll match anything. And then multi-line says go through different lines and match those. So these are the ones I typically use. You don't actually need all of these. We could start with none of these, but I just thought I'd throw them in there as options to begin. So the regular expressions, the power of them is, let's say you want to look up how many numbers are in the document. So this \D is for digits, and so you can find all of these in this Stringr tidyverse cheat sheet, and that'll help you go through what these mean. But the \D tells you numbers, so a digit. In most regular expression language, you only need 1 backslash. In Stringr, you have to put in 2 backslashes. So the 2 backslashes here are equivalent to a single backslash, like in Python or other languages that use regular expressions. So 2 backslashes says use a special character, and the special character is a digit. So then match this special character that's a digit, and then use these options. So we can count those, and it shows you that 346 numbers show up in the temp document. And so by numbers here, it means character digits. Well, what if those numbers are like, some of those numbers are 100 or 300? Well, we've counted, like, let's say in 300, the 3, the 0, and the 0 as separate digits that are numeric. Well, maybe we can do a little more. And here we're doing S is a space character. So here it says match a space character followed by a number character followed by a space. So if we count these, notice there are 10 of those, so much fewer than the 346. So 10 times it can match something that has a number that is surrounded by spaces. Well, that doesn't work quite so nicely, because what if you have other formats for the number as well? So let's see if there are other things we could do. So in regular expressions in Stringr, the parentheses tell it groups that are evaluated together. There are some other special cases of parentheses in other regular expression languages that we won't work on, but those are ones where you could save certain things. So there are lots of different tools that we won't go over here. We're going to go over the simplest tools. But here it's going to evaluate this group together, and it's going to evaluate this group together, and then here in the middle is we want to find a digit. Well, the or sign is this pipe vertical line. So here it's saying find a space or find a $sign. And we need to do double backslashes for the $sign, is because that also has a special meaning. So if you use something that has a special meaning and you want it to be not a special meaning, you also have to escape it. So we're escaping this $sign and saying we want to use literally the $sign rather than the function character. So find a space or a $sign followed by a number. The same thing is going to happen over here. The dot is a special character that matches anything, and to get it to only match an actual period or dot, then we want to escape it so that it's the literal dot instead of the special character that will match anything. Okay, so we want to find space or $sign with a number. After the number, find a space or percentage or a comma or a period. Run that. Now it finds 29, so we got a few more matches, and so notice we're slowly building up to a regular expression that we might actually want to match. So here, let's do the same thing. So space or $, afterwards space, percent, comma, or period. Then the difference here is this plus. So plus, what that does is it's a wildcard character that says match one or more. Down here you'll see the star. That is matching 0 or more characters. So here we're matching 1 or more of whatever happens here. So we're going to match a number 1 or more times, followed by this before it and this after it. So notice the number went up again. Now we're up to 103. So those are cases that have a space, $, one or more numbers, and then these things after it. Well, what if we have a case where there's a number that is followed by a comma, followed by more numbers? So this would be like something that is 10,000 or something like that. So got the same things here. Now we have a comma. This thing says match 0 or more times. So we probably won't have any that have 5 commas in a row, but here it'll say match comma or don't match comma, and then followed by numbers again, 0 or more times. So both of these, it can match if there's no comma and no number, or it can match if there's 1 comma and a number, or any combination of those. And then the final part is the same as we had before. Now we went down to 100, and that's because some of these numbers that we got before now have a comma in between, which would be like this, followed by numbers, and now we've eliminated these extra commas here. So notice I didn't put the comma in over here. All right, so we did this already here. Now, what if we want to actually look at what those numbers are? Here we can do the string extract all. So pull all of them out. And now we've got all of the examples that were pulled out that match those. So notice we've got a 2022 with a space after it. That matched this. We've got 19 with a comma after it. That matched this. We've got 30 with a percent after it. Do we have any other interesting ones? So a $5 and 50%. So we've got lots of things that are matching numbers. Here there was a new line and the number 10,000. So lots of different numbers that it matched in this. Now that's not really that interesting because we often don't want to just see a bunch of output of numbers, but it gives you an idea how to start working with these strings to try and figure out how to pull out information that you might like. So let's do a little bit more with that instead of these numbers. Let's try some other things that are related to that. So in this, you'll see they talk about, if you read the document, you'll see they talk about permits for government approval of things. So you could look in there and see where it says it, but let's see how many times it says that. So first, string detect, did it find that word in there? Yes, true is it found that word. String extract now is going to pull out the first time that it finds permit. So notice that's not all that informative, right? It found it and it pulled it out. Well, we could do string extract all, and it'll do the same thing. Now it'll output however many times it shows up, but it'll just be permit, so we don't get any other information about it. We could count how many times that permit shows up. Notice it showed up 3 times. So we're getting closer to something that might tell us information. So let's try something else. So what if we do permit and then I read through this so you could read through and see what happens, but we've got another special character here, that function, that says this part here, the question mark and then this arrow equal sign says look before the thing you're trying to match. So it's going to evaluate everything in these parentheses, and what it's going to do to it is to say, using this part that tells it what to do, look before permit and find this. So what we're going to look for is change and then anything. So the dot here, remember, is anything. So match change and then anything else. And here we can tell it specifically how many times. So remember, we had the star and we had the plus. Well, now you can tell it specifically how many times. We're going to say match anything 0 to 20 times. So what that does is give you 20 characters to go between change and permit. So find anything that says change, anything else for up to 20 characters, or none at all, and then permit. So does it find that match that we created in there? Yes, it does. So in here we found that change in the permit. So now let's see if we can adjust it a little bit more. So we have this beginning part, the same thing, and permit. Now this part says look after. So here, question mark equal signs is look after the thing that you're trying to look at here, permit. And it says anything, and we are going to look at anything from 0 to 10 times. So that's, again, up to 10 characters, followed by law. So change something about the permit and the law related to that. Does it find this? Yes. So, okay, now we have a sentence. Now, of course, you would only know these things if you went in and read the document and found these sentences, but it gives us an idea about what we might try and do. So let's do something slightly more interesting that can extract information that's around that. So again, we have permit, and then before and after permit, we have anything from 0 to 20 times, and then after here, again, anything from 0 to 20 times, followed by law, and then anything 50 times, and before here, anything 50 times. So what it's saying is not having a range here forces it to do 50 characters before, 50 characters after, and then whatever it finds in here in between change, permit, and law with these any 0 to 20 and 0 to 20 times, it'll pull that out. And we're doing string extract here is to extract everything. And notice it spit out basically the sentence we were looking for, and it didn't quite go to the sentence beginning or ending point, but let's look through what it gave us. So it's looking for change, so it found change, and go before the C and do 50 of anything. So this is 50 characters before C, these are 50 characters. Then it says after change, do anything up to 20 characters until it finds permit. So going here, it didn't need the whole 20 characters, but it used some of those. Then it finds permit. Of course, it's permitting. Not quite the same thing as permit, so maybe we want to rule that out, but that sort of gets us there. Then it says anything up to 20 times before it finds law. So permit. Didn't need 20 again, it finds laws. And then after it finds law, anything, so from W all the way to the end is 50 characters as well. So what I hope you're seeing with these sorts of tools is it gives you a chance to pull out things that you want to find, and there's lots of flexibility in how you pull those things out. Of course, if you first saw this, right, it wouldn't be very obvious what this means, and so learning to get comfortable with this sort of syntax is important. All right, so then let's pull out some other specific texts. Let's say anytime Elon Musk talks, then let's pull out here 100 words after that. So this string extract will only pull out the first instance it finds it, and then we'll stop. So let's go ahead and do that. Here it says Elon Musk, CEO, Zachary. So notice this was from the beginning. This is just listing who was on the call. So we didn't quite get where Elon is speaking. Here, what if we want to just pull a certain amount before Elon Musk is mentioned? So now notice we're going before and after. We're getting these return and new line characters, and then it's giving us a little information about what was here before. All right, let's try another time. Let's look before Elon Musk. What we have to find before is a new line, which we have down here, and then pull anything afterwards from 0 to 10. The question mark, when used by itself, says stop the first chance you get. So if it can find what comes after here in 2 characters, then it'll stop. But if it needs to go up to 10, it will. The reason this is necessary is because regular expressions use what is called greedy matching. Is it'll keep going until as far as it can to match something. We want to tell it don't go, stop the first chance it can. And then here it says after that find a return character. So notice we have this here. So it starts with a new line, ends with the return character. Now we've got just the beginning, the first time that Elon is mentioned. So it doesn't give us that where he's speaking, but it at least gives us an instance where he first is introduced. And if you go look into the conference call transcript, you'll see this starts to get to instances where he's actually speaking. So let's see if we can get a little closer. Same thing we had before. Before you get to this point, so notice this is a look before something. Then we have something here, okay? So look before something, find this new line and Elon Musk, then a dot for anything up until it first finds return new line, return new line. Well, that shows up in here, so it's basically a blank space in between lines, like double spaced. So get that, then afterwards find the same thing. It's gone to a new line. Well, then in between that, match anything, and from 50 to 500 characters. And what we're going to capture is this double brackets. We can define a set of characters, and the caret tells it not, so find everything that's not this stuff. And so what that's going to do is give us a chance to pull out anything that is not new lines. Well, now finally, putting all of that together, that gives us what Elon first said in the call, and then we can do the same thing, now pull out everything that is in the call. So this is every time that Elon talks in the call. So if you were interested in just finding, looking through the conference call and then having spit out what Elon has said, you could do that. Once we have tools that will allow us to start pulling out certain words and manipulating words, that opens up some possibilities for summarizing and understanding text a little bit better. One of the primary ways this has been done so far is to get a dictionary of words and then use that dictionary to say whether a document overall is negative or positive. So they call this the sentiment of the document. And so here we have one that is used in accounting and finance a bunch. It's a dictionary list of words, and this is in one of those packages. So we use get sentiments. It just creates a list of words for a dictionary, what it's called. And here, notice it says here are a bunch of words that are negative. Then here's some words that have other sort of meaning, constraining. We have a lot of different categories, litigious. Right, there's positive in here as well. Maybe, if ever I can find it. Positive words. So it's got uncertainty. So it's got these categories of words. I don't know what numbers are related to uncertainty. But it has categories of words that relate to things that that we might be interested in. And here we're going to just work on positive and negative words. So let's get out the positive and negative. So same thing we've done before. Take that dictionary, filter, keep only sentiment that is negative, keep only sentiment that is positive. I forgot at the beginning to tell you that we need the dplyr package in here. So then we get the words that are only positive and the words that are only negative. And we can look here in the negatives list, aberration, aberrations. Notice it has lots of different versions of the words. Abnormality, abolishing. So uses a big list of negative words and a list of positive words. Then we can force this into what we've been using so far. So we haven't used the paste function so far, but the paste function, what it does is take characters or outputs from other things and just basically print them out into a character. So here we're going to use the list of negative words, and you can combine a list of them by doing collapse. And so collapse, we're going to have this vertical bar here. So when we run this, it's going to create a character. So notice over here we have this character, and if we look at what it looks like, it's just all the list of the words that were in this dictionary of negative words, and they're all separated by this vertical bar. Well, this vertical bar is or, so it's just going through saying, look, abandon or abandoned or abandoning or abandonment. So it's doing all of these or statements for look for each of these pieces. Once we have that, we can then just count how many fit that pattern. So again, notice we have the same document. In the regular expression, it's going to input this negative, this pattern for negative that we did up here, and the pattern is this long list of words in a dictionary. And so we can just, it'll count through them. Now you can look, it says 196 words it found that fit into this. We can do the same thing for the positive words. And it says 143 words are in that dictionary of positive words. And then a typical way that this is done is to aggregate those together. So let's do the positive words minus the negative words divided by the sum of both. And that gives us a sentiment measure. So it's negative, so negative would be there are more negative words than positive words. If this were more negative than 0.15, then a document would be more negative. If it's, let's say, 0.05, then the document would be less negative. And so this gives us a summary idea of the sentiment of a document. It's not perfect, but it gives us some indication and gives us a tool. So a bunch of providers out there will do this for news stories, for earnings announcements, for Twitter feeds, for things like that, that will just track whether that particular document had more negative or positive words, which then maybe you could use to decide whether you're going to read the whole document or not, or to make other sorts of decisions. So this gives you a sort of overview of the underlying tools of textual analysis. Of course, we haven't spent a lot of time on every possible type of pattern. I've given you a bunch of the sort of basics. If you want to learn more, you could go in and read more about this in these regular expressions. The best practice really is try different things to pull out of documents. And the more you practice it, the more these sorts of regular expressions will become handy for you. And then the next class we'll get into some different tools that will allow us to look at a combination of documents rather than just a single document.